This is a quick video on Wan 2.1 scale model, and there is a tiger in the backyard. The example you are looking at is character replacement. Producing a long video in a single go will change the character. I don't think you will be able to get the name of this cartoon character. This is also an example of character replacement in a realistic-looking scene. Now I have decreased the number of frames in the load video node, and the character is recognizable.
Are you behind on your credit card bills? Good, pick up the phone and start dialing. Is your landlord ready to evict you?
Decreasing the length even further makes the character's appearance even better.
Are you behind on your credit card bills? Good, pick up the phone and start dialing.
So to process long videos with Wan model, we will need multiple K-samplers which uses the ending frame as their starting frame, or create a loop to make it work. The body movement captured and generated by the scale model is very impressive. And this example you're looking at is about motion transfer. The character in the original image has not been replaced. This is an example of character replacement, and it looks good with the background music added by me. This was the actual image I began with, which was further processed by the Flux model, which helped Wan model to produce perfect motion. The workflow looks bad, but it is simple and easy to understand. So this is the workflow, and the part below which uses the segmentation model is not active right now. But everyone is using it. The result generated without the segmentation model looks fine to me, and this is just to preview the video. Here is the model and a LightX2V LoRa being used. The prompt node and the clip encoder are present with the VAE. Below is the load video node, and the video is being cropped. The first frame of the video is previewed here. This will help us understand whether the subject is present in the cropped video. I want the motion to be transferred from the original video, sending the full video into the scale node. As you can see here, will increase the processing time, though the difference is marginal. So in such cases, I suggest using the cropped video by making this connection and sending the cropped video containing the motion to keep things simple. This is the video details which I had to look at while testing different videos. And below is the image uploaded, which I want in motion. I am not using this resize node because the image size is at 1024 pixels, generated by the Flux Klein model. The image is encoded and used above to create the latent video. Below is the segmentation model, which helps in collecting information about the motion from the given video. The number of objects I wanted in this example was 2. And both the objects and motion were targeted based on the prompt we typed here. In this example, there is a man and woman dancing. Keep it simple, and it should do the work. Similarly, the segmentation model is used again on the image we want to be in motion. In my case, I want the smoke to dance. The preview was visible a few minutes ago. Make sure after uploading an image and video, you bypass these nodes and check if the subject is identified properly. Both the human figures were identified with a simple prompt. And now you can use the information above to transfer the motion from video to image. I am not using it, but I was using this before when I took the workflow from the internet. You can try without it and should begin with a small test, which should not waste your time. You can try capping the number of frames to be loaded. Like I am testing for 2 seconds, which is 32 frames, at 16 frames for 1 second. And 1 extra frame as we always do. Activate the nodes and run the workflow. So on my 5060 Ti 16GB, it took around 70 seconds. There is some red smoke, but changing the prompt by specifying the color of the smoke properly will fix that. The rest looks fine. And the difference of using the segmentation model is not much. The time taken was around 80 seconds, and the difference is subtle. It helps in certain cases, but I will rather change the image using the Flux Klein model, and that affects the result significantly. This boxing video was made in a similar way. So, this is the original video, and I wanted to replace the character on the left. And this is the original image of Elsa I began with. With the use of a segmentation model, the Wan 2.1 FP16 model was struggling to generate perfect video. So I edited the image and placed the character inside the fighting ring. I am using the Flux.2 Klein model. This workflow is slightly different from the previous one, but before getting into the workflow, I took the actual boxing match from the internet and then edited the video in DaVinci Resolve and added simple music. In the original fight, the punch and the flying kick happened in an instant. But in the edited video, things are going slow and fast based on the music. Then the video was brought into Comfy UI, which goes directly into the scale node. I am not cropping the video here. I am decreasing the size here because I test on a smaller resolution. Note that I try giving large images and videos to the scale node so it can have more details. A video size of around 1024 pixels should not affect the video generation time. The below image is resized to the size of the video I want to generate, or else you may get something like this. This was happening when I gave the image of a different size. So matching this size is important. And the time taken was around 60 seconds. The result generated is acceptable. After one perfect result, you can make this value at 0, which should bring all the frames in the workflow. I will quickly do 81 frames and run the workflow. The time taken was 150 seconds, and the result is similar to what we saw at the beginning. So that was the simple explanation for using the Wan scale model. So that was it in this video. I hope the video was informative and interesting. The workflow and the media files will be in the description with the result I generated. I wish you an excellent day.